Hey guys, welcome back. In this video, I want to talk about one important aspect that is related to PUSCH. Okay, I started a new series in PUSCH. Okay, so under this, the concept which I want to talk here is CDM group, CDM group without data. Okay, so there are three, 1/2/3. So we will try to see the differences for all these three things, and we will see how these things are mapped in the resource grid, and also we will see all the relevant relevant concepts around this. Okay, I hope you will enjoy this. Before we are getting started, I want to announce something that on August 12th, okay, 10 a.m. for about 1 hour, I'm going to give a presentation on UC on PUSCH. So here is the Google form. Please confirm your presence. I will get the idea on how many people would be attending, and the concepts that would be covered are mentioned over here. Okay, so please share with your classmates, friends who are interested to join. So more information, you can contact me via email, or you can ping me in the LinkedIn. Also, let's say you want to book one-on-one session for any guidance or for any inputs that you need. We below the following topics. For all these things, you can contact. Whenever you post the high-level question to me while booking, then if I have inputs, then definitely I will confirm the booking. So you can contact me via email, or you can DM me via LinkedIn. Okay, so let's get started with the concept which I was mainly talking. Um, okay. Um, so I hope this is visible. Yes, right. So CDM group 1, group 2 and group 3. So these are the things we were talking without data. So first in the previous video, I was mainly talking about the config type 1 and config type 2. Okay, so this is a like a prerequisite, or if you already know this concept, that's well and good. So in case of config type 1, how are the DMRs allocated? So for now, I will take the mapping type 2, uh, and sorry, mapping type. I will consider mapping type A, and I will consider DMRS locations as 2, 7, and 11. All right, so let me go ahead and place my DMRS on symbol number 2. Let's say my starting PSH symbol is 0, and I have got number of um, number of symbols as 14. Starting symbol is starts with 0, and also I have just considered only 12 REs, okay, or 12 subcarriers for the sake of simplicity. So you can you will understand, I mean, if a higher bandwidth is given. So now, since config type 1, so first case is config type 1, how are my DMRs allocated? As I was explaining in the previous video, in the alternate arrays, starting with the first subcarrier, it will be allocated. Let's say, this is the case when this is the case for port 0. Okay. So now, this if we are talking about CDM group 1, then we are telling CDM group without data, things like that, right? Without data is PUSH data, or it can be PDSH data if it is in the downlink. So what happens is that usually this data will be occupied on those arrays. Okay, so first let me copy this 2 on 7 symbol and 11 symbol. Now usually the data will be occupied on like this, right? On the DMRS symbol, wherever there is a vacant array, the data is not occupied. But that is the case. Okay, this is the case when the CDM group without data is equal to 2. So, but if CDM group without data is equal to 1, there are features which will implement such a kind of concept. So, if group is equal to 1, then you will see that even the vacant REs are also utilized. So, vacant REs are also filled by data. Okay, I think you got the concept. Uh, So this is group CDM group 1 and CDM group 2. This is the difference. Okay. So now what about CDM group number 3? So that is used when when we are going to talk about a conflict type 2. Okay. For now what I will do, conflict type 2 I will take it. um, So config type 2, I will represent the config type 2 on symbol number 7 itself, okay, for the sake of simplicity. Um, mm, so first I will delete all of these things. Now how will my config type 2 look like? So it will be like this, right? And it will be, so it will be like this. So so now the thing is that this is nothing but your CDM group without data is equal to 3 in case of config type 2. Okay. Now if you are going to talk about CDM group without data is equal to 2, then what happens is that we have to place the data, right? So data will be placed something like this. So still two more REs, total 4 more REs will be vacant, but this is group 2. But if we say during config type 2, if we say CDM group without data is equal to 1, then in which case all the vacant REs would be occupied. So even these things are also would be occupied. I think you got the difference between CDM group 1 and 2 in case of config type 1 and CDM group 1, 2, 3 in case of config type 2. Okay, now let us see what are the other related concepts around this. Okay, first and foremost thing is that mm, so what is it? I mean, how does it help? It helps to improve the data rate throughput, right? So that you're not leaving out any vacant REs. That is first thing, that it improves the uplink throughput, or in the downlink if you're taking it, it improves the downlink throughput. Then the important concept which I want to talk here is with respect to the power. Okay, power. So see, let's say the power for this entire number of subcarriers. Let's say it is given as P. Okay, so let's say for symbol number 9, for this entire 12 subcarriers, the power is given as P. Now the thing is that the same power P can also be applied on symbol number 11. But you can see, right, that there are vacant REs. So out of 12 REs, there are only 6 REs that are occupied. So how can we actually you know give make the total power as P, right? So the power which should be allocated to this now can be given to this DMRS, which means that this will have, let's say, okay, P, right? So 12 is there. For each of them, if you are equally dividing P by 12. Okay. Now, since this 6 is there, this DMRS will take, 2 into P by 12. So two times the power is more for this DMRS, this DMRS. So total, I mean, if you actually add for all these 6, then finally the total power will become P. So this is one thing, and then you will see that in the DMRS, you will say, right, that in wherever DMRS is there, you will see that there is a 3 dB higher power. So this is the actually reason. So similarly, like what about in case of what about in case of um, I will take it here. So what about in case of CDM group? So if you see here, out of 12, okay, out of 12, only 4 REs are occupied, which means that, this is 3 times. So 3 times extra power can be given to these things. 3 times extra power means, actually 2 times means this is log to the base 10 of 3, this is coming around, sorry, log to the base of 2 times, so it is coming around 3 dB extra. So similarly here you have to do log 10 3 times, this will come around to 4.77 dB extra power. Okay, so this actually we can see in the spec as well, the whatever is given. So let me go to, so we need to go to 214 spec, that is what I have opened here. So I mean, just search for DMRS here. So directly it has gone to DMRS. So if you see in this particular table, right, so this is, you just please note that this is actually PDSCH to DMRS. Even this holds good for both PSCH and PDSCH. DMRS is in the denominator, so DMRS is higher power, so you are seeing minus 3 dB and minus 4.77. Okay, but if you take the inverse of this, where DMRS comes in the numerator, then you will see plus 3 dB and plus 4.77 dB. Can you see config type 1? Only alternate REs are there. So for CDM group 1 and 2, you will have a 3 dB gain for config type. I mean, in case of without data is equal to 2. But without data 3 comes only for config type 2. So that's why there is one more row, and for that you will see a gain of minus, I mean, 4.77 dB. I think you got this. Let me go back to this. Okay, that is one related concept. Then what else? The another thing is that with respect to ports. Okay, so here I was talking about port 0, right? Now port 0 and port 1, let's say port 0 and port, what port to be used here? Okay, see, if you are using CDM group number 1 where data is also occupied, uh, right, so in these, once data is occupied, you cannot go ahead and allocate a DMRS there. Okay, I will just take, see, when you are using two ports, which means that you have got two layers, two layers, so you will have two OFDM grid. Let's say this OFDM grid is for one layer, this OFDM grid is for second layer. Okay, so now what I will do, I will take just a copy of this and place it. So now you can see, right, since the data is available here, you cannot actually place the DMRS here, so you have to place the DMRS on same RE locations similar to the top what is present in layer 1. But in this case, then how do we achieve the orthogonality? Okay, so that is when you have to use port number 1, you will achieve the orthogonality with the frequency domain OCC. Okay, this also you can see in the spec actually. So let me try to take that 211. Okay, 211, I'm already in that. Okay, config type 1. If you see here, port 0 and 1. So in this, if you see, mm, okay, port 0 and 1, if you see actually, then so 0 0 delta 0 0 means both are starting from the same subcarrier. Then if you can see this WF of WF, which is a frequency domain OCC, if you see, this is plus plus 1 1 and 1 minus 1. So this is where you will achieve the orthogonality. Then I hope this concept is also clear. So the port allocations will actually differ, if you're using CDM group 1 and CDM group 2. Whereas however, let's say you're using CDM group number 2, which means the data is not available. I will take at the symbol number 11. Okay, so symbol number 11 where data is not present. So in which case, how can I allocate my DMRS? So I can start with from here, right? Now, if you see on port 1, this occupies on even REs, this on port 1, sorry, okay, this is on the first layer, it occupies on even REs, on the second layer, it occupies on odd REs. Okay, so both are orthogonal in the frequency domain resource allocations. So in this case, the frequency domain OCC will not come into picture. So in this case, this could be port 0 and this could be port 2. Okay, this also you can see in the spec actually. If you see here port 0 and 2, you see that delta is equal to 1, which means that it occupies odd arrays. You will see OCC is plus 1 for port 0 also plus 1 plus 1. I think you got the concept. then what are the related concepts? Similarly, different ports could be used for even config type 2. So I'm just thinking on the different other items which I can mention. Another one important aspect is see DFTS OFTM, right? So what is the important criteria for DFTS OFTM? The thing is that the allocation of REs or RBs should be continuous, right? So, um, so if you are going for CDM group number one, you see that the data are occupied alternate RAs. There is a gap in between. So this doesn't satisfy the condition required condition for DFTS OFDM. For DFTS OFDM, you need continuous RAs allocation. So whenever DFTS OFDM is enabled, you will see that you can only opt for CDM group number two. Okay, I think that is one important aspect which I wanted to mention. Um, then I hope this much should be fine for now. I think if I have missed any other critical concepts around this, maybe in the upcoming related concepts, I will try to cover. Okay. So note that here for different layers, different OFDM grid will be there. Different layers are dealt with different ports. Those things I have missed in the previous video, config type 1, config type 2. Okay, so if you're looking for more videos like this, please do subscribe to the channel. Thank you very much. Have a great day. Bye bye.